Right now we're going to start the third part of our tutorial on how to build our multi-rotor development kit. And the third part focuses on programming the Pixhawk flight controller. So we're going to use a program called QGround Control to do that. And what you're going to want to do first is grab a school laptop from the cart. They're numbered 1 through 10. You want to take a mental note of which number you get, and you're going to want to pick 1 through 9. I use number 10, and so all of my files are stored locally on number 10. You want to make sure that you just use the same computer every single day. So pick a computer 1 through 9, look at the back of the computer, and there's a long number. The last 2 digits are the computer number, and just get that computer every single day. And make sure you plug it in and charge it each afternoon when you're done so that it's not dead when you go to use it the next day. So the cart will charge it. Just do that at the end of the day so other students besides yourself can also use it. So once you've done that and you've gotten yourself computer logged in, you go ahead and click Q Ground Control. And right now it's a current version is a purple icon here. If you have a different version, we'll have to take it to the IT department. I believe there was one that did not get updated, and so we'll figure that out based on where you are. Now I already have a version of it running because I did something earlier. So I need to actually just go here. I'm actually going to pin it to my taskbar as well, so it's down here all the time. But I'm going to go ahead and open it. Okay, once you plug in your drone to Q Ground Control, you might not get it to connect for a while unless you're in manual mode. So you might want to go ahead and make sure that you're in manual mode first, and then at that point you're going to be waiting till it says ready to fly. And it might take 10 seconds to a minute to have this occur. So just make sure you're in manual mode at first, just because it might not get there unless you do that. First of all, when you get to this page, you're going to see a summary of what's going on with your drone, and this will summarize the current status of each instance of the programming. So you've got your airframe, your sensors, your radio, flight modes, power, safety settings, and camera settings. And so that's kind of similar to what you're going to see here. So this indicator tells you whether that status is ready or not, and green would indicate it is good to go. Red would indicate it needs to be set up. So in this case, this one is pre-programmed from what I did last semester, so it's already been done. So I'm just going to kind of flip through these, but I'm also going to do this recording after wiping it and starting from scratch. Last time I wiped it though, I had a few technical issues, so I'm going to go ahead and do the recording first just to get it done and make sure that I have it. So the very first thing you want to do is you want to update your SICK radios and your Pixhawk controller. So what it's going to ask you to do here is to plug your Pixhawk in with a USB-A cable to a USB-C cable. The A side will go into your laptop. The C side will go into your Pixhawk flight controller on the right side. Go ahead and plug it in and open this page, and then it's going to ask you, it says that it does detect two things. It detects a SICK radio, and it also detects the Pixhawk, and it's going to want me to unplug the Pixhawk from the USB. So I'll go ahead and do that, and that will force it to do an update. So it's a little easier to unplug it from the computer side on the USB-A side than it is from the flight controller. So go ahead and then unplug it and then plug it back in. And what that's going to do is it's going to force an upgrade. Now I've already done this upgrade, so I'm not sure it'll do it again just right after I just already did it. And also I have a SICK radio plugged in, so I'm going to unplug the SICK radio and I'll try that again. And on my computer, there is only one that works. So you want to make sure you have a powered port. There you go. So once I switched it to my powered port, you could see that the firmware asked what it wanted to do. And I wanted to set this up as an ArduPilot or PX4. So you want to make sure your PX4, we're currently at version 1.15.2. So pick that and hit OK. And that will go ahead and update your controller. And then the next step is you are going to want to upgrade or update your SICK radios. You have to do an update on both of them. And if you fail to do an update on those, you will not have the right settings in your sidebar. The settings we were just looking at, they won't be correct. You won't have actuators. And so you want to make sure you get those SICK radios both updated as well. And to do that, you're going to just unplug them just as we're doing here with our flight controller. So go ahead and give yourself a little time here to get the upgrade done, and I'll come back to you. Okay, we're all done with our Pixhawk upgrade. So now I'm
Mission flight mode. Pre-flight fail, strong magnetic interference.
I'm getting interference because I'm indoors. But at this point now I'm going to plug in my SICK radio with the black cord that is in your kit. And the black cord is USB-A to micro USB. So go ahead and plug that in. And because I only have one powered port, I'm going to go ahead and try to update that. So I'm going to plug in my SICK radio.
Communication lost.
Down into him. And I'll try to go to firmware. And it says it says right now that it can upgrade the firmware on the Pixhawk devices, such as SICK radios and Pix4 Flow smart cameras, but all QGround Control connections must be disconnected prior to the upgrade. So right now it's asking me to please unplug your Pixhawk and/or your radio from USB. So I'm going to unplug the USB-A side from the computer, and then I'm going to plug it back in. And right now it did find the SICK radio. So it should go ahead and do that update. Right now it's updating that SICK radio. And then when I'm done with this one, I'm going to want to do the same thing. I'll plug in the other SICK radio, which is mounted on my drone, and I'm going to go ahead and update that. So go ahead and proceed to do both these updates yourself, and I'll catch you back in a second. And just a side note, the only port on my school laptop that is working for this is the upper right USB-A port. The lower one is not powered, I don't believe. Okay, upgrade 1 on Flight Controller 1 is done. Now I'm going to go ahead and plug in the SICK radio number 2. The first SICK radio is done, and I just plugged in the second SICK radio, and it is noticing that it does have a device plugged in. So I'm going to go ahead and unplug this one. So go ahead and proceed to do both of your updates in the same manner. In order to make mine work, I actually had to switch out of the firmware tab. I tried plugging back in my flight controller, and then I went back to my SICK radio, and then I had to switch tabs to the summary tab and back to firmware tab. And now I'm about to unplug my SICK radio number 2 and wait a second, and then I'm going to replug it back in, and that should update it. There we go, it found that device. So it was a little trickery trying to get the second one updated, but just some troubleshooting. Was able to get mine to work. Hopefully yours just works. Okay, my update on my SICK radios is complete. So at that point, I'm going to plug back in my Pixhawk. It does get a little trickier in a minute here to do it this way because you're going to have to flip your drone from side to side. And so I'm going to go ahead and proceed. And the first tab here is summary. And what the summary tab does, it basically summarizes the current status of each instance. So is the airframe set up? Yes, in my case it's green, it's set up. And it's set up as a quadcopter generic version 1152. Then the sensors, are they set up? Yes, they're all ready to go. The compass, the gyro, accelerometer, and so on. The radio has been tuned to have pitch, roll, yaw, throttle. And then flight modes are set up. Got mission mode, stabilize mode, and position mode. Right now my mode switch is my channel 5 on my flight controller. And my mission switch is mode 1, my stabilize is mode 4, and my position mode is flight mode 6 on the radio. That's the position of the switches. And then now over here under power, got a battery. Under full battery, it's about a 4.15 volts, and an empty battery is about 3.6 volts, and it's a 4-cell battery. And then over here I've got my safety switches. So I've got a warning when the battery is on failsafe. If I have an RC loss failsafe, it's going to return the drone. If there's a timeout, it gives it a half a second before it starts to return. Right now the data link is disabled. And then if it was to return to land, it would go up to 98 feet before it returned back to me. If it returns to land, then it will loiter and land after a certain specified time. The loiter altitude is 32.8 feet, and the land delay is 30 seconds, and there is no camera on this drone, so those settings are not enabled. But this is indicating that these are all set up. But in order to teach you how to do this, we're going to wipe this flight controller and start from scratch, just like you guys are going to be doing. But just for the sake of the video, I'm going to go through this right here and show you all of these things. So right now, under airframe, you're going to pick what type of airframe you have, and you have a generic quadcopter. You can see there's all different kinds of fixed-wing drones or, hexcopters and so on, but you want to pick a quadcopter with the 4 rotors. Then under sensors, you're going to go under your compass, and you're going to need to go outside for this. Your gyroscope, you'll just leave your drone level. Your accelerometer, you'll leave it level and level horizon. And then you're going to go through what they call the dance with the different orientations of the drone. And here you're teaching it what the drone is like when it's on its side, its tip, its tail, its other side, front, back, and so on. And that teaches the drone all of its orientations. So your program. After you finish your airframe setup, you want to come outside, bring your drone kit outside, and you want to work on your sensors. And the very first sensor is the compass. So it's going to require you to be outdoors where you can get satellite signals. So come on out, bring your computer with your SIC radio, your drone, and your radio. And you're going to go ahead and go to the sensors button. And the very first sensor, like I said, is compass. So it's asking you if you'd like to rotate the compass within it, and because your arrows are all pointing forward, there's 0 rotation. If you were to put them on backwards, you might have like a 90-degree rotation or a 180-degree rotation in that case. But we don't want any rotation because we lined up everything together. So we're just going to say rotation none, and we're going to hit OK. And now it's asking you to put your drone in all these positions and do what the screen says. So in the first case, it wants us to rotate the drone to the left. So we're just going to do a spin until it gives us a green signal. So in my experience, it seems to be about 1.5 turns. Now it wants you to put it upside down. And when you hold it still, it's going to tell you to rotate it to the left. So again, I'm probably going to do a rotation and a half. 2 in that case, nose down, and just try to hold it as steady as you can and do a nice slow rotation. You don't have to go really fast, just kind of a normal speed. Nose up. This is often referred to as the dance. You're just calibrating all of the different directions that the drone could possibly face. So now it's on left, I believe. It doesn't matter what order you do this in though, because it will be able to read it. And I was wrong about that. It was the right side. Or actually that is the left side. Okay, and now the opposite side. By the time you're done, you might start to get a little dizzy. I definitely am. So we're about done. This is our last calibration. And so we should be able to go back inside and move on with our other sensors. Okay, and so now it says that your calibration is complete. You are going to want to reboot your vehicle for that to take effect. So I'm going to go ahead and do that right now, just so I don't keep getting a message. And there we go. Go ahead and hit OK. And we're going to move on to the gyroscope. Actually, you can do this outside. If you want to just finish it up, it just wants you to place your vehicle on a surface and leave it still. So I'm going to just click OK since it is on, I believe it's a level surface, so I'll say OK. And it's just going to take a moment, and now that's done. So we can also do level horizon out here if we'd like. To level horizon, you need to place the vehicle in its level flight position and leave still. So we'll say OK. It's going to go ahead and do that. And now it goes on to orientations. So again, we have no orientations. And so we just hit OK. All right, and it looks like we're done with the sensors. So at this point, we're going to go inside with our radios, and we're going to calibrate the radios. I am going to go indoors because it's bright out here and I can't see very well. Then at this point here, you're going to go connect your radio, and you're going to do a calibration. You'll be clicking this button right here and calibrate your roll, pitch, yaw, and throttle. And there are also some channels over here that you can use. So you can take a look at those, and it'll give you directions over here. We definitely want to be in mode 2 to set up our yaw and our up and down here and our pitch and roll over here. Then our flight modes. It's going to ask us what different flight modes we're going to program. So we're going to program the different channels. We are going to program are 1, 4, and 6. And we'll program mission, stabilize, and position. And then we'll also program emergency kill switch. In my case, it's channel 8. And then my return switch is channel 6. And then these monitors here will show you when you flip a switch on your control, whichever one is moving is the switch, so you can kind of identify what switch does what. When we get to here, we're going to program our power, and we're going to program that we have a 4-cell battery. Most likely our empty voltage is going to be around 3.6. Our full voltage would be around 4.15-ish, somewhere between 4.05 and 4.15. And that will be determined when you do some testing in our rest control room, and you're going to test your battery and see how strong your battery is. So your numbers might vary a little bit from that. And then it will calculate the voltage there. So that's what we do under the power tab. Under the actuator tab, we'll be using the PWM aux port. And so we want to use this tab. We don't want to use these tabs because we didn't use those tabs on our flight controller. So we're going to use this first tab and set up these settings. These are for our different motors when they're disarmed, what their ranges and their minimum range and their maximum range. These are PMW 400 Hertz motors, so we're going to use that. And then depending if you plug in more things to your auxiliary inputs, you might be using them here. At this point we don't, we just have our 4 motors. And you can also rev your motors up. If you turn the switch on, you can rev up all motors, or 1, 2, 3, or 4, just to test them and make sure that they're going in the right directions. Motors 1 and 2 should rotate counterclockwise, and motors 3 and 4 should rotate clockwise. So you're going to want to make sure your drone does that and your props are put on accordingly. And then right here, it's just got the X position, Y position, and the direction is showing that these two, motor 1 and 2, their direction is counterclockwise, and then these two are clockwise. So that kind of shows you which direction the motors go. So it's kind of good, gives you some good feedback there. And then now we go down to our safety tab. And under safety settings, we're going to set up, again, this is not a DJI drone. It comes factory blank. So what you want to do is set up your settings. And the fail-safe action is something goes wrong. What do we want it to do? We want it to warn us. And then it's going to warn us at 30% because that's our operation manual suggests that we come back. So at that first warning, you want to come back. The battery fail-safe is going to be level 7 and the emergency level is 5. So when you get to this page, this is your actuator page, and it's going to be working with your settings for your motor and how positive or negative the settings range from. So how high can you push it on one end of the spectrum to how low you can push it. And because we're plugging in our PWM to our first auxiliary port on the left, you're going to notice that anything on this tab has a little bit lower of a latency than anything you were to plug in on the right side. So instead of using these two settings, we're going to use this one because the lower latency means a quicker reaction time. So when we turn right, the drone quickly turns right. And that's what you'll get by using this port. That's what it's designed for. So first of all, your motors, you're going to want to put them all at 400 Hertz. And it looks like from reading the manual, this is set up for some landing gear or a parachute, which is pretty interesting. You could probably use them for other features as well, but we're not going to be using that right now. But that is a feature that is a potential to be used. But for right now, all we're doing is having our motors set up. And I had this configured for some reason, different motor setup. But then if you look at this diagram here, motor 1 turns counterclockwise, so does motor 2. Motor 3 and motor 4 both turn clockwise. And mine were set up this way. And what I did is I turned this switch on, and then I can easily rev up one of my motors and see that motor 1 is actually this one spinning. And then I'll rev this one up. Motor 2, make sure that on my quad, this one is spinning. And so on. Motor 3 should be this one spinning. And motor 4 should be this one spinning. So you can go ahead and do that. These were all messed up before, and so I changed them from motor 1, 2, 3, 4, and then they were correct. So now I may give you some updated settings for all of this, but when I'm looking at my radio, my TX, I see that the maximum and minimum settings are these settings right here, these values, something different. My aileron and my elevator and my pitch and my rudder, those are all slightly different. But since we're just doing the motors here, I'm going to put the maximum at 1969, the minimum 988. And this right now, I'm kind of waiting to see what setting to put those on. So I think we may put that at 900. And in order to change these, I have to shut off the motors. So let's do that. So I believe that the setting we're going to go with here is 900. But when you get to this portion, see me, and I'll tell you the exact settings because I'll have to have time to test it by then. So for now, just do 900. The minimum is going to be 988. So that's the far left. and the far right or far forward or backward would be 1969. So let's go with those settings for now until I tell you differently when you get to this point. Okay, so now we're going to go over to our safety settings. And we are going to, sorry, I had to move my radio farther away. So here are some programming items that you can go through to keep your drone safe. So this is a safety section. So we've got various things like return to land, return to home, things like that. So what happens if you have a data loss link? Is there a geofence and so on? So that's where these settings are going to come in. So we're going to kind of set it up similar to a DJI drone, although kind of tuned to aims and some of our rules we have here. So the battery failsafe action is a warning. It's going to warn us, and we're going to set that to 30%. The failsafe level will be at 7, and emergency level is going to be 5%. Obviously, we're not allowed to fly the drones below 30, so just be aware of that's why we're putting that at 30. We don't have anything to sense objects, so we don't have any, a sensor on the drone, so we're going to disable that function right here. And then down here, if our remote control has a loss of signal between the, telemetry on the drone and the actual remote control, what will happen? What's the failsafe? So the action, I'm going to put mine to return to home. You obviously can choose something different if you'd like. I probably wouldn't choose terminate or disarm, but you could have the drone hold, could have it return or land. In my case, I just think it's safer just to return it. And so if the loss of signal with the remote control is more than a half a second, and this happens just instantaneously, so a half a second is quick, but that's what you would need. So it's going to start to return. Then data loss. So if you get a lost link, I've gotten this several times with my DJI drone, if I was close to a building or had some sort of weird Wi-Fi issue, and my fail-safe action here would be to return. And that will happen if your drone loses a link for more than 10 seconds, it will start to return. The next thing is the geofence, and that will be how far your drone can travel, which just, fenced into our territory here on Ames campus. We don't want it to go too far. So if it goes out, the geofence goes too far away, this invisible fence I'm going to create, then I want it to return. I work for a drone show company. Those drones, they crash when that happens. So we've got these returning, or, you could tell it to land or something like that, but I want mine to return back to me. And the radius, the farthest that I want our drones to go is 1,500 feet. That should keep us safe. And the max altitude that I want our drones to fly is about 350 feet. These aren't as good as DJI, so let's not send them up there too high. So 350 is plenty high. Now, when we go out, you're going to change your return to launch settings. So depending on if there's 3 or 4 of us out there, or excuse me, yeah, your height settings, how far it will go if it returns to where it launched from. And so some of you might put you at 50 feet, some of you 100, but let's be 50 feet apart from one another and set up our drones accordingly. So for right now, we'll put it about 100 feet, but when we get outside, if you're with a partner, let them fly at 50, you take 100, the people to your right can take 150. So this will be if it returns to home. And you can also tell it to land immediately. If you hit return to home, loiter, so that means wait and don't land, or loiter and land after a specified time. So we've got ours set up right now. It's going to loiter for 30 seconds and at an altitude of 32 feet, and then it's going to climb to an altitude of 98 feet and then return to home. So hopefully, as you can see in this diagram, it flies over any obstacles, it comes back. The rate at which it lands, we're going to put it at 1.6 miles per hour and disarm after 2 seconds. The telemetry logging to the vehicle storage, we've got enabled, HITL enabled. I'm not really sure what those are, but looks like hardware in the loop simulation. So this is just a recommended setting. So we'll go with that. And that should be all of your settings. So now we're going to go over to PID tuning. PID tuning we'll actually talk about in class. There is some fine detailed things you can do with PID tuning, but you can also just auto tune over here. And if you click this while you're out flying, you can click auto tune and it will auto tune your PIDs. And these are parameters that your drone, how it reacts to things. So we're probably not going to get into too much depth of how it works, but there's integral and progressive and different types of things that you're tuning. That's what the PID stands for. I think it's derivative. But anyway, if you auto PID tune, it will do it all for you. And I have seen a drone flying really crazy. We did an auto PID tune and it flew perfect. So it does help. And what it wants is to get what it thinks the drone is doing and what the drone is actually doing to be the same thing. And so we want these blue and green lines to be basically right on top of each other. So if yours are far apart, then we do know you do need to pid tune. Okay, we're not going to get into flight behavior or camera because we don't have one. There are some specific parameters here that if you absolutely have to have something very specific, you can go to this, but I would avoid this if you can. The only thing you might do under parameters is you might come over to tools and you might reboot your vehicle. So that is one thing you can do here. But other than that, that's the settings we're going to go through. Hopefully you can go ahead and do yours, follow along with me.